the data of other users, then it will solve the collisted problem. Okay, there is no collisted problem because based on the similarity of the features of the contents, we can recommend. So if a new item is there, what we need to do, we need to find out the features of that new item, and then that is based on the content similarity, we can recommend that to maybe a user. So that's why we can see in case of the content based approach, there will be no collisted problem. And another there is good thing in our content based approach is able to recommend users with unique tastes. So that means as we can see, it is not required to know the other preference. So some of the users may, their likings may be totally different than the others. Okay. So even though we can recommend using the content based approach. Okay. And then third is able to recommend new and unpopular items also. Okay. If the item is new, uh, so and unpopular, then still if the similarity of that item is higher to the similarity of the item already watched by people, uh, then you can recommend that item also that people, even though that is not popular item. Okay. And then so there is no fast rater problem. Okay, so we don't need the ratings from any other, so no fast rater problem here. And another thing is able to provide explanation, that is the explanation why we are recommending this content to someone. uh, we need the explanations. But if we have the content based recommendation systems, then we will easily find out that is based on the similarity of the items. Usually we recommend. Okay, so that's why the explanation is very clear, so we can easily explain why we are recommending this content to someone. But what's the cons, what's the problem here in content based problems recommendation systems? The problem is appropriate feature. So extraction of appropriate feature is hard. So some images are there, maybe some movies are there, there's some musics are there, but you need to find out uh, the appropriate feature for the recommendation. Yes, we can find out some features, but we need to find out the appropriate features. That is specifically uh, first the liking of that user. The user like this movie because of the genre. We need to find out that feature. The users like this movie uh, because of the color, because of the presentation, because so that means there are several things. So we can uh, we can extract the features, but actually why the user like that movie. So to find out that kind of feature, to appropriately know that kind of feature is hard. And recommendations for new users, that means how to build a user profile. On that case, if we have the new user, uh, so that means on that case we don't have the user profile for that case. So that's another problem. And also offer specialization. Uh, so that means never recommends items outside users content profile. So based on the profile, maybe we can recommend something, but as maybe we can say that the profile doesn't uh, that is watch the movies, maybe outer domains in that profile. So usually the content based recommended systems will not uh, recommend those contents, those are not maybe in our user profiles. So that's another problem. uh, but we can also think about, like, people may have the multiple interest also. So in user profile, whatever the profiles at this moment, the user has. Based on that, we are recommending something, but we cannot explore the other interest specifically in content based recommendation approach. Okay, and unable to exploit the quality judgments of other users. Okay, so here maybe there are some likely minded people, and based on that we can also recommend uh, the content to the user. But in content based approach, we didn't consider the other people's preferences, so we didn't want to find out the likely minded people. Okay, so that's another cons in our content based approach. So specifically this one, based on the last limitation, uh, we develop another type of recommendation system that is called the collaborative filtering based recommendation systems. So in this case, what usually we do, we harness the quality judgments for other users. Okay, quality judgments for other users. That means usually we try to find out the similar minded or likely minded people, maybe who already whose preference is already similar to the preference of mine. So then, based on the watching behavior of those person, we want to recommend some content to our person X. So like here we can see, so maybe we can say this is the user X, and this users already watch some of the movies and also shows the preferences. Okay, so we have some preferences already for this user, and then these are also our other users. They also have some preferences. Okay, and we can see there is the preference of X and preference of this group, maybe n users, uh, maybe those are similar. Those are similar. Now we can see there is a new item is there. This is the new item. So this is our new item. And we can see that these people already watched that item and also uh, have some the preference. That means good ratings. Good ratings. Then as those people has the good ratings, we can predict that X may also like that item. X may also like that item because uh, the previously the X and these n people shows the similar preference. Okay, similar preference. So that's why we can term it like they are actually the similar minded people. Okay, so the new item may be new movie or maybe new song or maybe new document uh, is there. Then we can, based on the preference of these people, we can recommend that item to also X. So that's our collaborative filtering approach. So that means this X has the collaboration with these n users. So in such a case, what usually we do, find a set n of other users whose rating are similar to X ratings. Okay, so find set n of other users whose rating are similar to X ratings, then estimate X ratings based on the ratings of users n. Okay. Um, Now I think it's better if we can maybe see some of the examples specifically um, of our uh, content based and also collaborative filtering based approach. So at first we can see some examples here, content based recommendation systems. So let's say uh, we have the data set. Okay, the data set. So we have the data set here of 5 movies. like the Man from Nowhere, the Uchi, and then the Good, Bad, and Weird, and Doomsday Book, and White, the Melody of the Curse. Okay, so these are the 5 movies, and each and every movie we want to find out their features. Okay, the features are also extracted. Like if we consider about our 2 feature like x1 and x2, so we have 2 features, x1 and x2. We just extracted 2 features. In x1, we have extracted that is how romantic the movie is, and in x2, it is mentioned about uh, the action, whether the movie is action oriented or maybe no. Okay, so we can see the Man from Nowhere. This movie is a romantic movie. That's why the ratings for that, the feature value for that is 0.9, and action is maybe there is no action on that movie, so it is 0. The Uchi is another movie, and the score, the feature value, we have extracted the features. Whether this one is romantic or not, yes, it is romantic, and we can see the score is 1. And we the movie has few actions. On that case, maybe we can say 0.01 is the score in case of the actions. Similarly, we have another movie, that the Good, Bad, and Weird. So on that case, we can see this is also a romantic movie, and there is no action on it. But Doomsday Book, we can see that actually this one is the action movie. So action movie here is the 1.0, and there is no, there is a little romance on it. Okay, and then the White, the Melody of the Curse. This for this movie, we can see. Uh, the this is actually the action oriented movie. Okay, action movie 0.9, and romance is not there. Okay, so it's 0. So now what actually we want to do. So now we can see that we have also the user profile. Okay, so that is the features, those are features, and the Moon and Rim and Kim and Lee. So those are our 4 users, and they have the ratings. Maybe you can say Rim already watched the Man from Nowhere, this movie, and rate it like 5, and Uchi 5, and the Good, the Bad, and the Weird. Uh, Rim didn't watch that movie, and Doomsday Book actually Rim didn't like it, so that's why uh, he just rated like 0. Similarly, White ratings is 0 by Rim. And the Moon also has the preference, and like Moon watched the movie The Man from Nowhere and rated 5, and Uchi didn't watch. Okay, and then the Good, Bad, and Weird, we can see Moon already watched it and rated 4. And for Doomsday Book, the rate of Moon is 0, and the movie White, the rate is 0. Similarly, maybe Kim has some ratings, Lee also has some ratings. Now, as we can see, that is the Moon didn't watch the movie Uchi. So whether we would recommend the Uchi movie to Moon or not. So now our target is to apply the content-based recommendation systems, a content-based recommendation algorithm uh, to find out the predicted ratings of Moon to our movie Uchi. Okay, because he didn't the movie Uchi yet. Then if we consider that actually the movies here, total 5 movies, we can say, let's say the first movie is the movie A, and then second movie is the movie B, and C and D and E. Okay, so those are the movies. So Uchi is our second movie, that is the B. Uh, what we want to find out, we want to find out the similarity among the movies. Okay, so similarity we can see that is movie B. We have to find out the similarity among the between B and A. So here is the we need to find out the similarity between B and B and C also, similarity between B and C. And then we need to find out the B and D also, B and D, and also there is B and E. So here is the B and E. So that means we want to find out those similarity, B and D and B and E also. Okay, so those similarities we want to find out. Now, to determine the similarity, what we can do, maybe we can use some sort of similarity function. There are several similarity functions like Jaccard similarity, cosine similarity, K similarity. So we can apply those similarity function here. Any of those. Even the Pearson similarity we can also measure. Like say we have applied the cosine similarity. Okay, uh, the equation of cosine similarity to measure the similarity between two movies. The two movies means we can see actually those are the feature vectors. Okay, so the feature vector uh, B and feature vector C. So we want to find out the uh, uh, that is the similarity between the two vectors. So if that is the case, so now we can see B and A. If we try to measure the similarity, let's say we got 0.9. I have already discussed about how to determine the similarity uh, between two vectors. I think we can just apply that equation. We can apply that equation and maybe find out the similarity between A and B. So let's say A and B is 0.9. And let's say B and C is 0.8. Okay, B and C is 0.8. And then maybe we can say the cosine similarity between B and D. Uh, uh, here is a B and D. Maybe we can say this is like 0.4. And cosine similarity between B and A, let's say this one is actually 0.1. Okay, so now we got here, that is uh, the similarities between those movies. Okay, those movies. So now we have to consider that is the uh, how many there is similar items we will look for. Okay, how many similar items we will consider here to recommend the content. So let's say we will utilize, that is the k number of similar items. So k number of similar items, let's say k equal 2. So that means we will only consider two closest items similarity. So two closest item similarity. On that case, we can see the similarity between B and A is zero 0.9, similarity between B and C is 0.8, similarity between B and D is 0.4 and 0.1. So if we think about two closest items, then two closest items are, we can say that is BA and BC. So these are the two values. Those are greater than other similarity values. Okay, so we can take these two only. Okay, so that's why k equal 2. So we want to find out, that is k most similar items. So k equal to two most similar items. So most similar items, like now we can see this is A and C is actually the most similar, two similar items. Now we want to predict the ratings. One approach could be just one approach could be just utilize the ratings of these two items and then then just take the average of that. Okay, so like the ratings of A and C. So the ratings of A, we can see this is A and this is C. Okay, so ratings of A by moon, we can see this is 5. So moon 5. So here is the 5. Okay, so 5. And ratings of moon in C. So here is the C. Ratings of moon in C is 4. So here is the 4. Then we can see we have that is the two best similar items. We want to find out the average ratings of those two items, and 5 plus 4 divided by 2. So we will get the 4.5. Okay, 4.5. So this is this 4.5 will be the predicted ratings. Okay, so we can see this is 4.5. This is predicted ratings. We can find out the predicted ratings of the movie Uchi by Moon. So predicted ratings is 4.5. So we have also another sophisticated approach. The not only this, we can think a little more. Instead of just averaging out the ratings, we can think about like weighted average. Okay, weighted average, finding out the weighted average and finding out the weighted average ratings. So for that, what we can do for the weighted average ratings. So we can see the ratings of A. Ratings of A of moon is 5, and ratings of C of moon is 4. Ratings to C of moon is 4. Okay, and also the similarity between BA, the similarity between B and A. Similarity between B and A is 0.9. Okay, so this is 0.9, and also the similarity between B and C, it is 0.8. So here is 0.8. Then we want to find out the weighted average rating. So that means on that case, the rating, predicted rating, rating of moon on our movie B. It will be, so weighted average rating. So weighted average, in that case, we can see if we consider A, then rate is 5. Okay, moon's rating on A is 5 times the similarity between B and A, it is 0.9, and plus, now we have to think about the ratings of C. This is 4, and similarity between B and C, this is 0.8, then divided by, we have to uh, that is normalize it by dividing it 0.9 with the summation of the similarity values, with the summation of the similarity values. So 0.9 and 0.8. Then we will get some ratings here. Okay, some ratings here, and that will be the predicted ratings. Again, the predicted ratings of moon on the movie Uchi. Okay, and then if we can see that okay, this one is a good rating, then we can recommend that movie to Moon. So this is how the content based recommendation system works. Specifically what uh, we need uh, to determine the feature of each and every content. Okay, and then we need the user profile here. So now we can apply some other techniques also. Instead of just averaging out, or maybe the weighted averaging, we can also predict some the predicted ratings using some other methods. Like we can apply some sort of regression, um, some sophisticated regression methods also. So let's say we want to apply maybe some of the regression approach to find out the predicted ratings in case of the content based recommendation systems. So now we have to actually formulate this problem as a regression problem, and then after that, utilizing the methods or approach, uh, we can find out the ratings. Then how can we formulate this problem as a regression problem? Uh, so we can see that we have the feature like x1 and we have another feature x2. So based on these two feature, uh, can we predict the value, this one, as the regression value? Okay, so we want to predict the value here. So that means based on these two feature values, can we predict this one? What we have already, we have like already the data uh, for other features and the already regression value we have. Like if we consider about the first movie, this one. So the feature of that movie is given. So here is 0.9 and this is the action is 0. So feature of this movie is given, and also the related rating also given. Okay. So similarly, maybe you can say if we consider about the movie number 3 here, then the features are given and also uh, the ratings are given. Okay, features are given also for the 4 and rating also given for 5, ratings are also given. Okay, so if that is the case, then actually the problem we can see, we can think about this one is just a linear regression problem. Uh, or sometimes we can think about like multilinear regression problem. We have multiple features for that case. Uh, so specifically, the previously discussed approach is not robust. That's why it's better if we can utilize some of the robust method, like we can say there is linear regression or maybe multilinear regression, even the polynomial regression. Then how to form this problem? So what actually we want to do? So if we can think about like actually we have the data of the feature x and maybe feature x2. So let's say if we want to plot like this, so we have, maybe you can say we have x1 and maybe we have x2, and this is actually our ratings. Okay, r. So we have x1, x2 and r. So if we consider about the first movie, 0.9 and 0. Okay, so 0.9 and 0. Let's say this is 1. Here is this is 1, and ratings may be 1, 2, 3, 4, and 5. So for the first movie, you can say 0.9 and 0. Okay, 0.9 and 0. So 0.9 means maybe we will get 0.9. So maybe here, and then 0 is okay. So maybe we will get the data point this position. And then the second one is 1 and zero point 0.1. Okay, so 1 and 0.1. Then we will get the data set 1 and 0.1. Maybe we can say it will be maybe here data point, the second. And then the third one, okay, 0.1 and 1. Sorry, for the second one, I think there is no rating in second one. So we can remove it. For the third one, the third movie, we can see this is 0.99 and 0. Okay, 0.99, nearly 1, nearly 1 and 0. That is here. Then fourth movie, 0.1, and here is full 1. X2 is 1 and 0.1. So the 0.1 and maybe X2 is full 1 here. So that on that case, maybe we will get the data point in this position. This is for our fourth. And then the fifth movie, it is 0 and 9. So that means 0. You can see the x1 is 0 and y, that is x2 is 9. Maybe you can say we will get here. Okay. Now we can see we have actually x1 and x2, and based on the x1 and x2 we have the ratings. Now if we consider about drawing just maybe one best fitted uh, plane, okay, best fitted plane, or think about just line also, uh, then maybe we can draw a line. uh, Actually we need to draw the plane here because this is 3 dimension. Okay, so maybe we can say we can draw a plane like this way, uh, and then for any values of our x1 and any values of x2, we can predict the rating value for that case. If we can find out a regression line or regression plane. Okay, so on that case, whatever the value of x1 and x2, we can predict the value of this r. So that means we can think about this problem as a linear regression problem. So for that, the linear regression problem, specifically in linear regression problem, what usually we do, if we have just maybe there is the one dependent variable and one independent variable like x and y. So usually we need to draw the line. Okay, need to draw the line like y equal mx plus c. So this is the equation of a line. But in our case, actually we have two features, x1 and x2. That's why this one x, we can consider a vector and it has two components. Okay, so we can write it like this. That is y equal, here as you can see, this is x1 and then x2 and then c. Okay, then c plus c. Okay, and this is m. Actually you can say if we have just one variable, then the one slope we can consider, but we have two variables, x1 and x2, so we need to consider two slopes like m1 and m2. So m1 x1 plus m2 x2 plus c. Okay, then if we consider this m1, this m slope, those slopes are just theta. Okay, if we consider this one is actually the m1 is theta 1 and m2 is theta 2. Okay, so this m2 is theta 2, theta 2. So we can consider this one as theta 2. So m1 x1, that is the theta 1, and m2 x2 is theta 2. So on that case, we can write this one is theta 1 x1 plus theta 2 x2. Okay, theta 2, theta 1 x1 plus theta 2 x2. Plus of what? Plus of c. Okay, plus of c. Uh, then this one we can tune a little bit. Like we can write like this way. So here, instead of y, you can write the p, the predicted rating. It is actually the theta 1 x1 plus theta 2 x2, and instead of c, we can write this one as theta 0 x maybe x0. Okay, theta 0 x0. So theta 0 x0 we can consider. So now actually we can see that we can consider here uh, two vectors. Okay, one we can consider the vector of theta, and another one we can consider the vector of x. Uh, so like here we can see this is the vector of theta. So in vector of theta we have theta 0, theta 1 and theta 2, and in vector of x we can consider x0, x1 and x2. So for the movie, maybe for the movie Uchi, it has the feature vector. Feature vector, that means we can say for this movie, actually it has the feature vector. The feature vector values x0, x1 and x2. We can consider x0 is 1, x1 is 1.0 and x2 is 0.1. And uh, for the theta, we can consider that moon has the theta, and the theta is theta 0, theta 1 and theta 2, where theta 0 maybe after determining that we got this 0, and theta 1 is 5 and theta 2 is 0. Okay, so specifically we can see theta 0 x0, theta 1 x1 and theta 2 x2. If we want to find out uh, the values of theta 0, theta 1, theta 2, those are actually our learning parameters. Okay, learning parameters. So those are our learning parameters. In case of the linear regression, I think many of you already know about that. And we will also discuss the linear regression specifically for big data in another lecture in our big data machine learning, that is chapter. On that chapter, we will also discuss it. But what usually we need to know now, the learning parameters here are the theta 0 and theta 1 and theta 2. Because we have the x1 and x2, and the x0 also, we assume that the starting from the 1, that is kind of the c, the value of c we have started from 1 like this. So here is theta 1 x1 and theta 2 x2 and theta 0. So now we have to learn theta 0, theta 1 and theta 2. There are several approaches for finding out the optimal parameter values of our theta 0, theta 1 and theta 2. Like you can think about least square method to find out that. Um, so I think, yes, I have a lecture on it. Um, so as I already mentioned that it can be the linear regression, or maybe it can be our uh, that is multilinear regression or polynomial regression. Okay. So on that case, you can see that actually our equation will be like this. Okay, equation will be like this: the beta 0 plus beta 1 plus beta 2, okay, beta 3 and beta 4. So in such a case, if we try to apply the our maybe least square method, or we can think about like gradient descent approach, uh, then the equation will be like this. Okay, so this is yi minus y hat. So what is it? Uh, that is the yi is original value of y, like the original rating, and this is the predicted rating. So then we have to find out the difference of original minus prediction. So usually we call it the residual, and then this is a square. So this is a square residual. Then we have to sum up for all. So that means this is actually the sum of square residuals. Okay, sum of square residuals. And then we have to add something that is called our regularization. Uh, so regularization components we have to add. Um, Otherwise, maybe you can see that it will be fit like this way, and for that uh, the variance will be high on that case. That means it will be overfitted. Okay, overfitted. To reduce the overfitting, what we need to do, we need to add some regularization parameter. Okay, and on that case, maybe instead of fitting like this way, the curve will fit like that way, and uh, so on that case, the regularization component we need to add. So that means we can see that the beta here, beta j, those are actually the regularization component. Okay, specifically this is called the ridge regression, and we have the this part, and in this part this is the sum of square residuals, but we have also the another part. This is called generalization, uh, and we have the regularization constant also. Okay, so this constant, actually this is called regularization parameter that controls the trade-off between 1 and 2. So this part and this part. uh, so that means if we consider lambda is huge, or uh, the larger value, actually uh, to minimize this, it will consider all the beta value at 0. Okay, so that then it will not solve the problem. So we have to sincerely take the lambda value, not so big, not so small, uh, and we can see how many there is regulation parameters we need to take. That will depend here. Maybe you can say the value of p. Uh, so in this case, we can see actually this is the formulation of the problem, specifically for the content-based recommendation algorithm. So what we initially we have to do, those are the theta values. Okay, those are the theta values. So like here you can see those are the theta 0, theta 1, and theta 2. And we can see we have to consider for all users and all movies. So we can see here the moon. For the moon, we can consider maybe this equation. And for RIM, maybe we will get another equation. So that's why here is the theta 1. Theta 1, maybe these thetas are for RIM. Theta 2, this theta maybe is for moon. Uh, Theta 3 maybe for Kim, and theta 4 maybe for Lee. Okay, so that's why we have considered here there is theta 1, theta 2, and theta nu, that is number of users. For each users, we have to consider different theta values. Okay, different theta values, because this is not only we need to optimize for the moon, we have to think about another users also, other users also. So that's why maybe solving this problem, uh, we can we can find out, or we can find out the optimal values for RIM, for moon, for Lee. That means for all users. So then what actually we want to do, we want to find out the theta value by solving the following objectives. Okay, so in this case, what are the objectives? The objectives is we can see this is y of ij. What is y of ij? This is the actual rating of I for j. J, the I is movie and j is the user. Okay, so the rating for, like, if we consider y11, so y11, so it means that the original rating given by RIM to the movie A. Okay, to the movie A. So that is the original rating. So this is the rating actually. This is the rating, original rating of RIM for the movie. This is A. Okay, so movie 1. So that's our y ij. And how about this? This is actually the predicted ratings. Predicted ratings. So predicted ratings are theta and xi. So we can see that is uh, this equation. Actually, this equation we can consider about the uh, we can vectorize those values. Okay, so consider that we have a vector theta. Consider the theta 1, and then in the theta 1, what we have? We have theta 0 and theta 1 and theta 2. Okay, and we have the x. Specifically, this one is for if we consider second movie, the xb, and then maybe we have the feature values, the x0, then x1, and then also x2. Okay, now if we think about like this equation we can get how we can get that one. So theta 1, we can transpose it.
স্যার
If we
আপনি
trans
যেখানে টাইপ করছেন ওই ইকুয়েশনটা ওই ইয়াটা দেখা যাচ্ছে না
দেখা যাচ্ছে না,
না
টাইপ
স্যার
করতেছি।
যেখানে আপনি এই যে লিখছেন ওই ওই ইয়াটা দেখা যাচ্ছে না
স্যার আপনি কি স্ক্রিন শেয়ারিংটা অফ করে আবার একটু অন করবেন? স্ক্রিন শেয়ারটা মনে হয় ইন্টারাপ্ট হচ্ছে স্যার।
এখন কি দেখা যাচ্ছে?
জি স্যার, দেখা যাচ্ছে।
দেখা যাচ্ছে স্যার।
ওকে,
স্যার একটু জুম করলে ভালো হয়।
জুম। Um, okay, now we can consider theta 1. We can consider theta 1 is theta 0, theta 1, and theta 2. So for this equation, theta 0 x0 plus theta 1 x1 plus theta 2 x2. For this equation, we want to vectorize it. So for that case, the theta 1, that means this equation, if we consider about the theta for moon. So on that case, we can consider this is the theta 2, maybe theta 2. So in that case, we have theta 0, theta 1, and theta 2. Okay, so theta 0, theta 1, and theta 2. And and we can consider the feature vector xb, x0, x1, and x2. So here's the x0, x1, and x2. Now if we transpose the theta, so that means we have theta 2 and we want to transpose it. Then if we transpose it, then it will we will get theta 0, then theta 1, and then theta 2, like this way. Okay, and if we multiply the theta transpose, specifically this is 2 if we consider, and the transpose and xb is xb. So what we will get, this is theta transpose, so this is the theta transpose, and then we have to multiply with x. So x is our x0, x1 and x2. Then what we will get? We will get the equation that is theta 0 x0 plus theta 1 x1 plus theta 2 x2. So this equation we will get. So actually theta transpose x will give us the predicted value like here. Okay, this p is our predicted ratings. So predicted ratings is theta 0 x0, theta 1 x1 and theta 2 x2. These predicted ratings we can find out that using this equation, that is theta transpose x. Okay, theta transpose x. Here in this equation we can see that actually this is the prediction. Okay, so theta j transpose x of I. Okay, so like here this is theta j, maybe if we consider j equal 2 and I is our movie b. Okay, then theta transpose x, this is actually the predicted ratings, and this is actual rating yi and j, this is actual rating. So this is the subtraction. Okay, so subtraction, it means this is residual, and then the square of that, this is a squared residual. Okay, and then we have the summation here, this summation for user j to n, that is the user n. So for all the users, and here is I for all the movies, all the movies, but we can see that all the movies are ij equal 1. That means those has the rating, those has already ratings, only we can consider those, because those don't have the ratings yet, we cannot maybe consider those things. So that's why here is the summation. Okay, for all the cases. And then this part actually is for the regularization. Okay, this part is for the regularization. Here is the theta k of j and square of that, the regularization part for each and every users and for all the movies also. And the lambda here, lambda is our regularization constant. Okay, regularization constant, as I already have shown that one here. Okay, so here is this is our sum square residual and the regularization parameter, regulation constant here. So that means this is the regression. But now how can we solve this optimization problem? Okay, we can solve this optimization problem different methods. uh, the the Adam optimizer, Adam methods, Newton's methods, and then we can utilize LBFGS. We can utilize the gradient descent, the Lagrange optimization. Uh, so if we apply this one to solve this one using our gradient descent, okay, then what actually we need to do? We need to take the derivative of this equation uh, based on the theta. Okay, so take the derivative of this equation. So this is the equation, and then if we take the derivative, then these two, that is, we can say theta x minus of y. So if we take the derivative with respect to theta, then this is actually we have to apply the chain derivative principle. Okay, chain derivative principle, because this is not actually theta, this is theta x minus y whole square. So we can say it will be like 5x plus maybe y whole square, like this. If we consider the theta here, then if we take the derivative, then what we will get? We will get like here, there is 2, then 5x plus y times this part we have to take the derivative with respect to with respect to again with respect to, maybe you can say, so let's say this is actually y equal 5x plus maybe c, 5x plus c. Then if we take the derivative with respect to x, so then it will be dy by dx, dy by dx, dy by dx equal what? It will be 2, then 5x plus c, 5x plus c, and then we have to take the derivative of this part again because this is chain derivative, okay, chain derivative. So that means we will get, if we take the derivative with respect to x, then it will be so times 5, only 5, okay, only 5, and c, this is constant, so 0. So that means we will get dy by dx, it will 2 times 5x plus c times 5, okay, we will get this one. So similarly we can see if we take the derivative of this equation with respect to theta, then what we will get finally, we will get this equation, okay, theta k minus, here is the specifically we will get this part, this part. So here is the theta x minus of y, the whole square, the 2, actually it will it will just maybe come in front. On that case, here is the half. This half is taken for the mathematical benefit. So 2 and half, so the 2 will cancel out, okay, cancel out, then we will get only this part, this part, and then the x k of I, okay, so this one specifically from this part we will get, and then for gradient descent, um, we need to update the value based on the learning rate also. The learning rate, learning parameter here is alpha. So this alpha, so that is theta k of j minus this one, that is previous value minus our gradient times the learning rate. So that will be the equation for our that is theta upgradation. So theta upgradation, and for initial that is the step or initial parameter or initial iteration, so we can consider k is equal 0, and for that case specifically no need to consider about our regularization, and then for the rest of the iterations we need to consider our regularization parameter, okay. So for there is the k number of iterations if we consider, then for initial iteration k will not be considered, that means regularization is not necessary, then for other cases those are necessary, okay. So on that case we will get these theta, and if we solve this equation, then we will get the theta, and based on that we can find out predicted values of x and theta. So specifically we can see this is the gradient descent approach. Those who already know about it, I think they understand this one, but actually this is also another lecture, and I will also talk about the gradient descent in that lecture, okay. So just what you can you can know from here, that means in content-based recommendation systems, we need to find out, we can convert the problem to a regression problem, or we can say polynomial regression problem also, and then we can utilize the formulate that problem using our polynomial regression problem, or we can say Ray's regression problem, and to solve that we can apply the gradient descent, okay, gradient descent, we can apply the gradient descent method to find out the optimal values of theta, okay, optimal values of theta. Now utilizing this theta we can predict the reading. Okay, utilizing this theta, we can predict the reading. And for prediction, we will utilize this equation, theta transpose x, theta transpose x. Okay, so theta transpose x will provide us the predicted reading. Like we can think about, like if we consider uh, about our linear regression problem, if we solve it, maybe we will get the theta 0 equal 0, theta 1 equal 5, theta 2 equal 0. And we have already that the feature vector x0 is 1, x1 is 0.1, and x2 is 0.01. Now if we just perform this operation theta transpose x, okay, then we will get some value, like maybe we will get 5.0, and on that case this will be the predicted reading for that case. Okay, this will be the predicted reading for that case. So there are some operations also. That means we can see that for this case we need to know the feature vector values, and there are some optimization methods. Even though we don't know about the feature vector values, we can formulate that problem and we can find out actually the optimal value of theta. Okay, optimal value of theta. That means even though we don't know those values, if we uh, that means we can say if we can formulate that problem, that means we don't know even x and we don't know even theta, still we can find out the optimal values of x and theta utilizing these equations. Again, we can see this is actually our uh, our residuals, sum square residuals, and then this is our regularization for our theta, and this is our regularization for x. Okay, and if we apply the gradient descent, uh, then we can update the theta value, and also we can update the x value. Okay, uh, and then finally we will get the optimal x and optimal theta also. That means uh, maybe sometimes we don't have the x and we have only maybe we don't know even the theta, and then still we can solve this problem. That means we can find out the theta and x. Okay. uh, So now I think I can discuss about the collaborative filtering. Okay, the collaborative filtering.
স্যার, আমাদের ল্যাসো অ্যান্ড রিগ্রেশন এটাও কি আরেকটা লেকচারে কভার হবে, মানে কন্টেন্ট বেজের জন্য?
আমরা বিগ ডেটা মেশিন লার্নিং ডিসকাস করব, সেখানে হচ্ছে রিগ্রেশন প্রবলেম আমরা নিয়ে ডিসকাস করব। তখন হচ্ছে আমাদের গ্রেডিয়েন্ট ডিসেন্ট হচ্ছে আলোচনা করব। তো গ্রেডিয়েন্ট ডিসেন্টের সময় আমরা যখন রেগুলারাইজেশন ইউজ করব, তখন এই রেগুলারাইজেশনটা আমরা ইউজ করব আর কি। স্পেসিফিক্যালি এটাকে আমরা রিগ্রেশন হয়তো বলবো না, কিন্তু রেগুলারাইজেশন আমরা ইউজ করব সেখানে আর কি।
ওকে স্যার।
Okay, then we can discuss about the collaborative filtering. As I already mentioned about that, that is what we have to find out. In this case, we have to find out the similar-minded people, and then based on their preference, we want to recommend the new items. Those may be already preferred by those similar-minded people, and it is most likely that uh, maybe our user X also will also like those items because X and those users are similar-minded. Okay. Uh, so now again we have to think about this to find out the similar-minded people. That means maybe we have the user profile. Okay, user profile, and we want to find out the similar minded people. That means the profile will be the same or similar. And for that, several similarity metrics, again, those are necessary, like the maybe consider the Jaccard similarity measurement. Okay, Jaccard similarity measurement, cosine similarity measurement. So already we discussed about the cosine similarity, and also the Pearson correlation coefficient. Okay, so this is also another similarity, that is kind of the correlation, but a little bit different. Um, and now if we talk about the Jaccard similarity measurement, okay, so we need to measure the similarity, but in case of the Jaccard similarity, we need to measure, that is the Jaccard similarity. Some of the similarity measurement method, there are some others also, okay. Uh, so Jaccard, okay. So Jaccard similarity measurement, we can you can see this example to find out actually how to calculate the Jaccard similarity. So if we consider that we have two sets, then we want to measure the similarity between these two sets, and then the Jaccard similarity measure of these two sets, it will be the, we can see number of elements, that is the union of sorry, intersection of C1 and C2 divided by the union of C1 and C2. Okay. So in this case, we can see that if we want to find out the Jaccard similarity between these two sets, the given like C1, we have the C1, this one is our C1, and this one is our C2. Then if we want to find out the Jaccard similarities, what usually we need to do first, the intersection of C1 and C2. So how many points you can see here, those are in intersection. Intersection means both in C1 and C2. Okay. So these are the elements. How many elements are there? 3 elements. Okay. So 3 elements in intersection. Okay. Then we have to divide it by uh, the length of the union of C1 and C2. Okay. The cardinality of the union of the C1 and C2. So cardinality of the union of C1 C2, it will be, we can say how many, that means the total elements. Okay. So 3 and 2, 5, 5 and 3, the 8. Okay. So total 8. So that is the similarity. This is called the Jaccard similarity. So what actually the Jaccard similarity measures? It measures just only present or absent. Okay. Present or absent. So in case of our actually user ratings, in case of our user ratings, we can consider like Rx, okay, the rating of X. So maybe the first movie, uh, 1 star, second movie didn't watch, third movie didn't watch, and fourth movie just 1 star, uh, and fifth movie 3 stars. Okay, 3 stars. Then the vector we can write like this way. The Rx, this is the one, that is our we can say 1 star, and then 0 and 0, here is the 0 and here is also 0. Okay, 0 0, and then here is the 1 star. Okay, and here is the 3 star. Okay, 3 star. Okay, and let's see, 3 star is 3. Okay, 3 star is 3. Now ry, okay, ry, we can say another, maybe another user y. Then the first movie 1 star, so first movie is a 1 star, second movie is didn't watch, so 0, and third movie is maybe 2, and fourth movie is also 2, then fifth movie is 0. Okay, fifth movie is 0. Now if we want to find out the similarity using the Jaccard similarity measurement method, then what we will get here. So as I already mentioned, that Jaccard similarity, it will only see that is whether it is present or absent, whether it is worst or not worst. It will ignore the ratings, actually the rating value of the rating. So for that case, the Jaccard similarity between in this case the Jaccard similarity J similarity between our Rx and ry will be, in such a case, it will be, so you can see set rx and set ry. So what are the common and what are the total? So common, how many commons are there? So you can say that the first movie is common and the third movie is common. Okay, so common, that means two common divided by the total. So total ratings, we can say 1, 2, 3, and 4. So the second movie actually didn't watch by any of the users, so we have to exclude this one. So 1, 2, 3, and 4. So that means 4. So Zakat similarity between Rx and Ry will be 2 by 4, that is 0.5. Okay, so that means we can apply the Zakat similarity, but again, you can see that means it is just whether you watch or not. You watch means maybe your similar-minded people will watch also. Okay, the cosine similarity, I think we have already discussed about it, so no need to discuss it again. You can find out the cosine similarity between the vectors. And then Pearson correlation coefficient. Okay, Pearson correlation coefficient. Now think about SXY items rated by both user X and Y. Okay, so that is SX and Y item rated by both X and Y. So we want to find out the similarity between X and Y. So using this Pearson correlation coefficient. So here, how to do that? So we can see that is, this is the summation of S, which is the element of SXY. It means SXY is the items rated by both user X and Y. Okay, both user X and Y. So here R XS minus of RX. So RX, this is actually the average rating of X. Average rating of X. Average rating of user X. So and RY is the average rating of user Y. So RSX minus of X. So if we think about the rating here, to consider this is Rx. So then we have to determine the Rx of, there is a the average. Okay, so mean Rx. On that case, you can see 1 plus 1 plus 3. So mean will be 3 for 5. So 5 by 1 to 3 total 3. Okay, and then Ry, it will be 2 2 and 1, that means 5 by 3 also, 5 by 3. Then RSX, the value we have, we can see for Rx the value is 1, the first one, it is 1 minus of Rx is 5 by 3. Okay, and then we have to sum up for all. Okay, and times this one times Rys minus of Ry. So Rys, you can see it is also 1 minus of R, the average value of Ry is also 5 by 3. Okay, that means same, 5 by 3. Then plus the next one. The next one, we can see none of the users watched this movie. And for the third one, actually, person X watched, but person Y didn't watch. So that means we should not consider, because RXY is the items rated by both user X and Y. So one user rated, but another one didn't watch. Okay, so we need to consider then the third one. The third one is 1 and 2. Okay, so on that case, this is plus. So 1 minus 5 by 3, it will be 1 minus 5 by 3. And then times and then second is 2. So 2 minus 5 by 3. Okay, so 2 minus 5 by 3. It will be 2 minus 5 by 3. So that will be our numerator, and in our denominator we can see actually this is the square root of summation of Rx minus x whole square. Okay, Rx minus x whole square times then the square root of Rys minus of Ry whole square. Okay, so I think we know how to compute Rx minus x whole square. So Rx minus x whole square is 1 minus 5 by 3 whole square, and then we have also plus of 1 minus 5 by 3 whole square, and then a square root of that. And for another one, that is for this part, it will be 1 minus 5 by 3 whole square plus of 2 minus 5 by 3 whole square, and then a square root of that. So we will get the similarity between x and y. That is our Pearson correlation coefficient. That's kind of the similarity. Okay, so this is how we can determine the Pearson correlation coefficient also. So either we can use the Jaccard similarity, cosine similarity, or Pearson correlation coefficient. Okay. Now I think we can discuss a little more. So let's say we have like A, B, C, and D. Those four users. Those four users A, B, C, and D. And then there are several movies here, like the HP one, this is Harry Potter 1, then Harry Potter 2, Harry Potter 3. This is Twilight, and then Star Wars 1, Star Wars 2, and Star Wars 3. Okay, so these are the movies. And then A, that is movie, user A has the ratings on Harry Potter 1, 4, Harry Potter 2 didn't watch, Harry Potter 3 didn't watch, and Twilight has the rating 5. Star Wars 1 maybe 1, and maybe other movies are not watched or rated. Similarly for B, also 5, 5, 4, and others are not watched, like this way. So now the interesting fact we can see here. So if we want to measure the Jaccard similarity, so similarity, that means similarity, we can see we want to find out the similarity between A and B and similarity between A and C. So A and B, that is, this is A and B, and also the A and C. A and B and A and C. So that is, we want to find out the similar minded people, okay, similar minded people. Then for that, maybe we need to calculate the similarity A and B, and then A and C, and then A and D, maybe B and C and D, like this way. So like if we think about, like there is whether we want to recommend the Harry Potter 2 to the user A or not, okay, or what will be the predicted rating for Harry Potter 2 for the user A. Okay, so if we want to find out that, then at first we need to find out the similar minded people in collaborative filtering. Okay, so similar minded people. So to find out the similar minded people, we can apply maybe Jaccard similarity or cosine similarity, or even the Pearson correlation. So let's say if we try to apply the Jaccard similarity, then what will happen here? So Jaccard similarity, in this case, we can see if we want to measure the Jaccard similarity between A and B and also A and C. So A and B and A and C. Let's say at first try the A and B Jaccard similarity. So A and B, that means A has this vector, or set, and B has this vector, okay, or set. As I already mentioned that that is in Jaccard similarity, whatever the ratings, that's not the thing we need to consider. The thing is whether it has the rating or not. Okay, so for that case, in case of our Jaccard similarity, we can see the similarity between A and B will be 1 by 5. Why 1 by 5? The intersection between A and B, intersection between A and B, so intersection between A and B, we can see between these two users, just only one is common. Okay, so this is the common thing. Harry Potter one, both A and B watched the Harry Potter one, and none of other movies are common. Okay, in commonly watched list. So that's why in our numerator we got maybe 1, and the denominator we can see at least the 1 value will be okay, because that is the union. Okay, so union, that means 1, 2, Harry Potter 1, then Harry Potter 2, Harry Potter 3, Twilight, and Star Wars 1. Okay, so total 5 movies are there. So that is 5. So divided by 5. So the Jaccard similarity between A and B is 1 by 5. And similarity between A and C. If we consider A and C, then the common between A and C is, we can say, Twilight and Star Wars. So 2 common, okay, 2 common. So that means 2. And if we consider about the union, A and C, on that case A, that means HP1, then maybe Twilight, yes, Twilight. So 2, then SW1, that is Star Wars 1, is also 1. So 3, and then SW2, Star Wars 2 is also was by C, so 4. Okay, so total 4. So here is the 4. So 2 by 4. Okay, 2 by 4. So 1 by 5, and then 2 by 4. Now we can see that if we consider about the Jaccard similarity, then 1 by 5 is less than 2 by 4. 2 by 4 is 0.5. Okay, so 2 by 4 is 0.5 and 1 by 5 is 0.2. So that means 0.2, and another one is 0.5. So that means similarity between A and B is less than the similarity between A and C. Okay, less than. But if we think about, if we now consider about the cosine similarity between A and B and A and C, then actually you will find out that it is 0.386, and it will be 0.322. That means similarity between A and B will be 0.386, and similarity between A and C will be 0.322. So on that case, we can see 0.386 is greater than the 0.322. So Jaccard similarity and cosine similarity result in different things. Okay, that's the opposite things. So that means similarity between A and B is less than the similarity between A and C. So in such a case, the closer item, or closer, or we can say that is the most similar minded people of A is C. in case of the Jaccard similarity. And if we apply the cosine similarity, the most similar minded people is B. Most similar minded people of A is B in case of cosine similarity. So that means this is the opposite. Okay, this is the opposite. So it means there are some problem in Jaccard and cosine similarity measurements. So yes, the problem is in case of our Jaccard similarity, actually it didn't consider uh, the rating, that the value. It just considered the whether that movie is watched by that people or not. Okay. So that's why it's better if we can apply the cosine similarity. But there are some ways. Again, there are some problems. Specifically, if we try to apply even the cosine similarity or maybe any similarity functions. So for that, uh, we need to we need to apply some extra measures. We need to take some extra measures for that. And what's the problem? The problem is usually we call it uh, the problem of rater's biasness. Okay, rater's biasness. This is very common problem in real life also. That means uh, some of the raters, those are hard raters. Usually we call it hard raters or tough raters, and some are just easy raters. Okay, easy raters. So in this case, maybe if you can think about like A is uh, the easy raters. The easy raters will start the rating from maybe 3 to 5, maybe 3, 4, or 5. But maybe another user B, he can be maybe the tough rater, difficult rater, tough rater, hard rater. Maybe he will start from 0, rating from 0. Okay, 0, 1. Maybe 3 will be the maximum rating for that case. Then this problem we can solve. That is the biasness, the rater's biasness. We can solve using using the methods. Okay, so what we can do for eliminating those kind of biasness, specifically we can utilize the method of resolving the rater biasness. Um, what's that? So you have to subtract the rho mean. Okay, you have to subtract the rho mean from each and every values. Then what we will get? That is, we can say, if we consider about our A. So what's the mean value of A? We have to subtract the mean. So subtract the mean. On that case, we can say 4. Here is the 5. Here is the 1. Then the total is 10. Okay, the rating of A is 10. Total rating is 10. 4, 5, and 1. So 10. And then if we consider about the average, so average is 4, 5, and 1 divided by 3. Okay, divided by 3. So this is 3. So that is for A, it is 10 by 3. Okay, 10 by 3. So what we have to do, we have to subtract this value 10 by 3 from each and every rating. So if we subtract that, maybe 4 minus 10 by 3. Okay, so 4 minus, if we think of it is 4 minus 10 by 3, then what we will get? We will get like 12 minus 10 divided by 3. That is 2 by 3. So we will get 2 by 3. So here we can see the 2 by 3. And then again, we can see for the toilet it is 5. So 5 minus 10 by, so 5 minus 10 by 3. But we will get 5 minus 10 by 3. So it is 15 minus 10, that is 5 minus 3, and that is 5 by 3. Okay, so we will get 5 by 3. For the our server 1, server 1, it is 1 minus 10 by 3. So it is actually negative negative 7 by 3. Okay, negative 7 by 3. So we will get here, negative 7 by 3. Okay, so negative 7 by 3. Similarly, we have to subtract the mean value. Okay, subtract the mean value from each and every rater, from each and every rater, and then we will get, that is those values. If we just sum up the rows now, then every time you will get the 0. Okay, every time you will get the 0. Then the rater's biasness will be removed if we do this. That means the subtraction of mean, if we subtract the mean from each and every ratings, and then the biasness of the ratings will be removed. That means whatever the value, maybe tough rater or maybe the easy rater will provide, so it's the remedy of our the rater biasness problem. Specifically, uh, after the subtraction, we can again apply some sort of normalization also, like the min max normalization, to find out the ratings within maybe 0 to 1, or maybe some other values also. Okay, some other values also for ratings. Maybe after that, you can convert the rating again from 1 to 5. Then you will see that the biasness actually removed from uh, uh, those ratings. That is our tough raters and easy raters problem. Now we count the similarity, and now we want to find out the ratings. Okay, the predicted ratings. So in case of the collaborative filtering, how can we determine the predicted ratings? Okay, so that means maybe we find out the similar minded people, and then we can see that similar minded people rate one of the movies, and then we want to predict the ratings of that movie, mm, of an unwatched movie of user A. Uh, uh, um, by looking at the ratings of similar minded people. Okay, then how can we do that? So from similarity metric to recommendation, in this case, let Rx be the vector of user X ratings. Okay, user X ratings, and let N be the set of K users most similar to X. Okay, most similar to X, who have rated item I. Then prediction for item S of user X, what will be the predictions? Then again, we can see that the rating of user X on item I, the predicted rating, it will be the summation. Here as you can see, the summation of the ratings of yi. Okay, yi. So that means I is the item, and y uh, is our similar, that is the similar minded people. Okay, ratings of similar minded people. So if we consider about k similar minded people, again, if we consider k equal 2, on that case, k equal 2, that k equal 2, then the rating of our that is most similar minded people plus the rating of our that is the second similar minded people, and then divide by 2, that is the 4 here. Okay, 5 plus 3 equal 2. So we can find out using this method. I already discussed this method actually in uh, our content based recommendation for predicting the rating. So similar here in content based prediction based on the content similarity, but here this one is based on the user similarity. Okay, user similarity. So we can find out this, and another way we can also find out the weighted method. Okay, that is find out the ratings using the weighted ratings of similar minded people. So for that case, maybe you can say this is the rating of the most similar minded people, and the most similar minded people has the similarity 0.9 plus of, then the second similar minded people, that is the ratings for that is 3, and the similarity for that person is, we can say 0.2, divided by the similarity summation of the similarities of the most similar and maybe second similar person. So this is how you will predict the ratings of different items for a given user X using our collaborative filtering based approach. Now the last topics I think I want to discuss here in today's session, that is called the item collaborative filtering. So as I already mentioned about that, in collaborative filtering actually we are trying to find out the similar minded people. Okay, similar minded people. Specifically we call it the user collaborative filtering. Okay, user collaborative filtering. But collaborative filtering also we can apply item to item collaborative filtering. But what's the difference? Then what's the difference between our content-based and item-to-item collaborative filtering approach? The difference is in item-to-item collaborative filtering, we will not find out the feature vectors or features of items. So we will only consider the user ratings uh, for the items. Okay, for the items. If we can see the previous example. So in this case, we can see that is if we want to apply here, like if we want to apply content-based recommendation, then these features are necessary. Okay, these features are necessary. But in case of our item-to-item collaborative filtering, item-to-item collaborative, we don't require those features. Okay, we only require this data set. Okay. So in case of the item-to-item similarity, so it will just look those ratings. Okay, it will try to look those ratings A and B and B, A and C and A and D like this. Okay, those ratings instead of considering the features. Okay, so user collaborative filtering, and then so in item to item, for item I, what you need to do, you need to find other similar items. And these similar items we have to find out based on the ratings of I based on maybe other similar items. And we can use the same similarity matrix for prediction of user to user model. Okay, so whatever we discuss about the similarity matrix and user to user, that we can also utilize here in item to item. So let's say one example is given here, like these are the movies and these are the users, okay? And you can see the ratings are given. And here these are unknown ratings, okay, unknown ratings, and we have the ratings in yellow grades, and those are between 1 to 5, okay? Those are between 1 to 5. And now what we want to do, maybe we want to estimate the ratings of movie 1. This is movie 1 by user 5. So this one we want to predict. This one want to predict. Then what we have to do, so that means we can see the that is the movie number 1. We need to find out the similar movies, okay, similar movies, but uh, uh, without utilizing the features of those movies, okay? So based on the similarity only. So now we can see we can find out the similarity between this one and all other movies, okay? So 1 and 2, 1 and 3, 1 and 4, 1 and 5, and 1 and 6. The vectors are there. That means we can see this is the vector of movie 1, and then this is the vector of movie 2. Okay, then maybe vector of movie 3, 4, 5, like this way. Then here actually we have used the Pearson correlation similarity. In this case, we have determined that, and you will get the Pearson correlation similarity. These are the Pearson correlation similarity. Now again, if we think about, like, we have k equal 2, okay, k equal 2, or we can say here that is in collaborative partner, we want to find out, like, n equal 2, okay, so k equal 2. So if we consider k equal 2, then we have to find out the most similar two items, okay, two most similar items. And based on the similarity, this is the 1, okay, so 1 to 1, it will be, it must be 1, okay. So that means now we want to find out that is two most similar items. So we can see that the similarity of 1 and 6 is 0.59. This one is the highest similarity here. And then another one, we can consider this one, okay, 0.41, this one. So considering these two movies, like the item, so item, that means movie 1 and movie 3, and movie 1 and movie 6. So those are very similar items, okay, similar items. And now we can see that actually for item 3 and item 6, the users ratings are, these are the ratings. One is 2, another one is 3. And utilizing this value, we want to predict the value of this. Okay, I think we know how to do that, okay. So if we want to apply that is weighted average for prediction, on that case, it will be, this is 2, okay, so here is the 2, and then the similarity between 1 and 3. So similarity between 1 and 3 is what, 0.41. So here is a 0.41, and then this is 3, okay. For the 6, this is 3, and the similarity between 1 and 6, 1 and 6 is 0.59. So here is 0.59. Then we have to divide it by the similarity here, similarity, summation of the similarity of 3 and 6, okay. So that is 0.41 and 0.59. So we will get 2.6. So this is actually the predicted rating of user 5 on movie 1, okay, using the item to item collaborative filtering. But the common practice is we have to think about, like, maybe some combined approaches, okay. Not only the item to item, maybe not only the collaborative filtering, not only the content-based recommendation systems. So here one common practice of our recommendation system is uh, adding the baseline estimation. Adding the baseline estimation. Uh, so that means we can say the ratings we will calculate using this equation, and we can see that actually what this equation is. So if we define the similarity as ij, that is for item I and j, item j, the similarity Sij. Okay, so here Sij, this is the similarity Sij, and then we actually in case of this equation Sij we have directly multiplied with this R jx. Okay, so the ratings, but instead of that, what we can do, we can subtract the baseline. Okay, subtract the baseline for that. So previously the equation is this equation. Actually this one is the equation before, Sij and Rxj. So instead of that, what we can do, maybe um, we can subtract the rating deviation. Okay, so subtract the rating deviation. So what does it mean by the baseline estimation for xi? So baseline estimation, the baseline estimator or rxi, it is the mu. Mu is overall mean of movie ratings. So overall mean of movie ratings. That means if we consider uh, about these are the movie ratings we have already. Then we have to think about the how many ratings are there and summation of. So we have to uh, find out the summation divided by our, there is uh, number of ratings we have. Okay, so that will give us the mu. Mu is our overall mean movie ratings, and then we have to add the bx. So rating deviation of user x. So rating deviation of user x, it will be the average rating of user x. Like if we consider about this user 5, then the rating deviation, that means we have to sum up all these ratings and then divide by the number of rated movies. Okay, so that will provide us the bx. Bx is rating deviation of user x. So average rating of user x we will get, and then we have to subtract the mu. Okay, so this mu, overall mean movie rating. So that will give us the bx. So bx. Similarly, we have to think about I, that is the items also. So it will be the rating deviation of movie I. So rating deviation, how to compute that? The rating deviation of movie I, think about like if we consider about movie 1, the rating deviation will be the average of the ratings of movie 1 divided by the average of the ratings of movie I, then subtract the mu from that. So subtract the mu for that, then we will get bi. So here is the bi. Okay, so this will be our baseline estimator, and then the ratings. Previously we have calculated the RXI in this way, but now a little bit change over there. That means we have to subtract the baseline from our R x of j. Okay, Rx of j. So here is again, if we want to find out this, that is bx of j, then it will be again the mu plus the bx plus the bj. Okay, bj. So the bj, this is the bi, that means we can say item I, and the similarity measurements we usually need uh, uh, two items. One is I and another one is j. So here is the I. We have to utilize the I in this baseline. and we have to utilize the J for this baseline. Okay, then we will get a better estimation of the ratings, because adding this baseline estimation actually uh, it will also help to reduce the biasness. Okay, so that's why this practice is better. This practice is better than just utilizing this method. Uh, so if we want to compare item to item and user to user, these two, then we can observe that actually item to item works better than the user to user. Uh, uh, because that is the case is the users have multiple tests. Okay, multiple tests. So that's why usually in case of the recommendation system, it's better if we can consider the item to item collaborative filtering, and then maybe apply some baseline to estimate or correct the estimation also. Then first the pros and cons here in collaborative filtering. So the good thing is works for any kind of item. Okay, any kind of item, it works for the collaborative filtering. So that means we can say no feature selection is needed for that case. But for the bad thing here, that is uh, you may have the cold start problem. You may face the cold start problem. So cold start problem, that means in case of our maybe you can say the new items, there will be no ratings for that. So on that case, you cannot recommend that new items to someone. And the sparsity is a problem because you can see there is the users and items are many, but only few users will have the rate for that. And also you will face the fast rater problem because a person, if you didn't get any ratings on any items, then actually it is difficult to recommend something to that fast rater. Okay, and the popularity biasness is in collaborative filtering. Popularity biasness actually, if you get that is the uh, a item that has been rated by many users, then it is most likely that that is a popular content, and you will actually uh, recommend that content to some others also because uh, because it has the popularity bias. Okay, so that's it is mentioned that tends to recommend the popular items. Okay, because those items are actually rated by many users. Okay, so you have the ratings for almost many users, so that's why maybe those users rate will be higher also because of the popularity, and uh, so always it will recommend the popular items to different users. So that's why the hybrid methods is better. So implement maybe two or more different recommenders and combine the predictions. Uh, so that will be better. Uh, so it will actually uh, remove the problems of collaborative filtering, and also it will remove the problems of our content-based filtering also. So that is add content-based methods to collaborative filtering. This is kind of the hybrid approach. So on that case, you will have the item profiles for new item problem, and also sometimes the demographics will deal with the new user problem also. Okay, so that means the hybrid approach for the recommendation system is better for us. But now the thing is, there is we need to measure the item to item, or we need to measure maybe the user to user, or maybe we need to measure the content similarity, but we need to find out the similar items. But the problem is if we have the big data, then how to find out the similar items? Because to find out the similar items, like if we want to find out these two items, we need to maybe load this data, and that means the whole data set, okay, to compare with the whole data set. But as in big data, we can see we don't have the memory, enough memory to load the whole data set to a memory. Then how can we determine the similarity among those vectors? So that is problematic. And for that case, we need to apply some special mechanism. um, It is usually we call it locality sensitive hashing. Okay, locality sensitive hashing. Uh, so I think we should start this one, the locality sensitive hashing, in our next lecture to find out the similar items in context of big data. Okay, so that's all in our today's lecture. Thanks everyone for joining this session.
Sir, the recorded session will be uploaded in our Google
Yes, it will
Drive.
be uploaded. It will be uploaded in our
Okay.
Google Drive.
And I was not present on the last Thursday due to my medical conditions. So, how can I get the lectures and notes? The notes already some slides are there. I checked that, but if I face any problem, then I can come to the consultation time or any free time.
Yes, you can visit BRACU in my consultation hour. But
All
before
right.
that, you have to go through the slides and try to
Yes,
understand.
if I find any problem, then
Okay, yes, okay,
sure.
no problem. Okay, thank you.
Thank you.